Good afternoon, all of you. Today's topic is mole concept. Now, take 10 apples. How do you hold these 10 apples? Do you need a basket? Can you answer? Or do you hold all these apples in hand? Hello? You need some basket or can you hold
Yes,
with
yes, sir.
hand?
Yes. We need a basket.
You need some basket. Okay.
Okay.
Now here 10 apples are shown here. Imagine 100 apples. To hold 100 apples, do you need a small basket or a big basket?
Big basket.
Very good. Very nice answer. Now let us imagine, say, wheat grains. See how wheat grains are there. Can you count these wheat grains?
No, sir. It's
No,
not possible.
you cannot. You cannot count these wheat grains because
Because there are so many wheat grains.
so many, number is very large, and of course they are very small. Can you imagine the weight of this wheat grain, each grain? Approximately
Maybe 1 gram, sir.
maybe 1 gram or less than 1 gram. Okay. Now, see, let us see atoms and molecules. Atoms of an element are shown here, molecules of an element, molecules of compound. Have you ever seen atom or molecule of a compound or element?
No,
Have
sir.
you ever? No. Why?
Because they
Why
are
not?
really invisible to our eye.
Yes, atoms or molecules are very small in size. You cannot see those very small sized atoms or molecules of any substance. Now, have you ever seen brick?
Yes, sir.
What is the purpose of the brick?
To construct houses, sir. Houses,
Yes.
buildings.
So, brick is used for the construction of a wall. See, this is the
Yes.
wall. And of course, so many walls are put together one after the other in different directions, different angles. We get the house. So, bricks are used
Yes.
to construct a wall and thereby a house. Thus, brick is the building block of wall or house. Can you apply this knowledge in case of atoms and molecules of element or compound? Then what
Yes,
is
sir.
the building block of element?
Molecule.
Yes, building block of elements. It's not molecule, it is atom. Building
Atom,
block
okay.
of compound is molecule. Okay.
Molecule, okay, sir.
Now, elements are made up of atoms. Atoms are very small, and compounds are made up of molecules. So here,
Okay.
let us write something. Elements. So what is an element? An element is a pure substance made of same type of atoms. Made of same
Same type of atoms.
type of atoms. Okay. Can you name some elements which you know very well? Element. What is that?
Chlorine.
Chlorine. Very good. Very nice. Chlorine is an element. So its symbol is Cl. The symbol is written. It has a 2-letter symbol. C is the capital letter, the first letter, and L is the small letter, the second letter. Chlorine is an element. It is pale yellowish green gas. Pale
Right.
yellowish green gas. Okay.
Yes.
Can you name some other elements? Can you name
Oxygen.
some other elements? Say
Oxygen.
Oxygen. What is the purpose of oxygen? Do you use oxygen in your daily life?
Yes, sir. To live. Without oxygen, we
Yes.
can't live.
In respiration. So, oxygen is very useful in respiration. In fact, without oxygen, we do not have life. No life, no oxygen. If there is no oxygen, there is no life. Some other elements are hydrogen. Hydrogen symbol is H. Nitrogen symbol is N. In fact, this oxygen, nitrogen, they are present in air. Air is a mixture of oxygen and nitrogen. 99% of air constitute of nitrogen and oxygen. Now let us see a compound. Compound. Do you know what is compound? Compound is made of two or more elements. Two or more elements. Can you give some example of the compound which you are drinking every day? Water is an element. Sorry, compound. Water is a compound. Water is a compound of oxygen and hydrogen. Oxygen and hydrogen. So compounds have molecules. Molecules. So molecules of water. The molecule has a formula. Formula. Formula of a water molecule is H2O. Each molecule has 2 atoms of hydrogen and 1 atom of oxygen. 1 atom of oxygen. So this is element. So element is the pure substance made up of same type of atoms, or an element is a pure substance which cannot be broken into further simpler substances. Whereas a compound is made of 2 or more elements. Okay. Can you give some more example of compound? Can you give one more example of compound? Yes. What is that? Common salt. And of course, carbon dioxide is also a compound. Common salt. Common salt is NaCl. Okay. See, as you told just now, atoms or molecules are very small and they are not visible to normal eye. Right. Now, elements, so many elements are in our body. Not only our body, even animal body also. Animal body and the human body is made of a variety of elements. For example, most of the body is made of carbon. Do you know what is carbon? Carbon is an element which is available in the Earth's crust in the form of coal. Coal is the agent of energy. If coal is burnt, lot of energy is released. So energy is required for running various industries and other things. Coal is also used for generating electricity. That means one form of energy converts into another form of energy. So strictly speaking, you and me are made of carbon. For example, see, this is the hair. What is this? This is a hair. One hair. Okay. There's a black in color. See the thickness. What will be the thickness approximately? Maybe 1 millimeter. Do you know how many atoms are present in the thickness in 1 millimeter? Is it 10? Is it 1 or 100? Can you guess? How many atoms are present? Yes. What is that?
We cannot guess.
Of course, it is approximately 1 million atoms. 1 million means 10 lakhs. In the thickness of hair, there will be 1 million of atoms. That means you can imagine the size of the atom of an element. So how many atoms of carbon are there? In the width of a single hair, 1 million carbon atoms may be present. Sometimes it may be more also. Now let us see the gold. Have you ever seen gold?
Yes, sir.
What is the color of the gold?
Yellow.
Yellow. Very good. Nice. See, this is the gold dust available in the Earth's crust. See, you are able to see the small speck of gold. Strictly speaking, in this small speck, there are millions and millions of atoms. Again, you can understand the size of the atom, how small it is. Potassium chloride. Potassium chloride, what is the formula? KCl. So this is the potassium chloride, which is white in color. See, this is approximately maybe 10 grams of potassium chloride. How many ions are present? So this potassium chloride has a K plus and Cl minus ions. How many ions? Again, we cannot measure, we cannot tell, because the atom or ion or molecule is very, very small, and it is not possible to count the number of particles present in this small amount of the substance. See, this is the periodic table. Periodic table means a systematic arrangement of elements in the increasing order of their atomic number is a periodic table. Why it is referred as periodic table? Periodicity means repetition after regular intervals. So the properties of elements repeat after regular intervals of their atomic numbers. For example, here hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. They are in the same vertical column, which we call it as a group. The elements present in a group, they show similarities in their properties. That means after regular intervals of atomic numbers, say lithium is 3, sodium 11. After regular intervals of atomic numbers, the properties repeat. That's why it is referred as periodicity. Therefore, this arrangement of elements is referred as periodic table. Okay, now let us take oxygen. See here, oxygen. Right? Oxygen, almost every element is available in the isotopes. Do you know what is isotope? Isotope means isotopes are atoms of same element, having different mass numbers. So here, oxygen, atomic number 8, mass number 16. Again, oxygen, atomic number 8 and mass number 17. And oxygen, atomic number 8, mass number 18. So these three are isotopes of oxygen. Now let us see, the three different isotopes are available. Then how do we find? See, mass numbers are 16, 17 and 18. See, remember, mass number is not the atomic mass. What is meant by atomic mass? Atomic mass of an atom is the exact mass of all the fundamental particles present in it. What are the fundamental particles? Electron, proton and neutron. Okay, the sum of the masses of all these electrons, protons and the neutrons present in the single atom is referred as atomic mass. Right? Now, let us calculate weighted average. What is meant by weighted average? These three isotopes are available in the nature to different extents. O8-16 is available in 99.76%. O8-17 is available. The relative abundance is 0.04. O8-18, the relative abundance is 0.20%. Now, as we have the relative abundance and the atomic mass of each isotope, we can calculate the weighted average. How do we find weighted average? The first isotope is 99.76 into its atomic mass is 15.9949 plus the second isotope, the relative abundance is 0.04 into 16.9991 plus the relative abundance of the third isotope, that is O8-18, is 0.02 into this is 17.9991. So after calculating, we get this is 159595.6512 plus 0.6799 plus 3.5998 by the total abundance is 100, then we get this is 15.9993. So this is weighted average. Weighted average. Weighted average means average weight of all the isotopes available in the nature. Whereas atomic mass means one particular atom. This is O816 has atomic mass of 15.9949. Right. Now, like this, we can calculate the weighted average of each and every element. But keep the point in mind, whether it is weighted average or atomic mass, for the calculation purpose, we take the mass number of the most abundant isotope. Here, the most abundant isotope is O816. So, since it is the most abundant isotope available in the 99.76, therefore, this mass number 16, we take it for calculation purposes, since we can do calculations in an easy manner. Have you got this?
Yes, sir.
Okay, let us proceed next. Atomic weight and atomic mass. I told you already, atomic weight means weighted average. Weighted average. Atomic mass means mass of each element. Mass of each element. Okay. Now, gram atomic mass. See, previously we discussed that calculating atomic mass, that means mass of an atom, is very, very difficult. Right? Even we feel very difficult in counting the rice grains or wheat grains in 1 kilogram because the number is very, very large. So, atoms, for example, mass of an atom. Atom is of any element, approximately, mass of an atom, approximately is 0.00 how many zeros are here? 3, 6, 18 plus 20. 166. So much. Right. See, can you measure this mass?
No,
this
sir.
is
No.
approximately 10 to the power 1.66 into 10 to the power minus 24 grams.
Well,
This is very difficult because it is we do not have a measuring instrument to measure such a small quantity. So, in order to avoid this difficulty, a concept was introduced, that is gram atomic weight or gram molecular weight. Now, just now we discussed that average, weighted average of oxygen, how much we calculate? 15.9993. So, if we express this in terms of grams, then this is known as a gram atomic weight. So, 1 gram atomic weight of oxygen atom is 15.9993 grams. Because there are 4 digits after the decimal, this is also creates a problem in calculating. That's why we make it a round figure, that is 16. What is this 16? It is nothing but mass number of most abundant isotope of oxygen. Most abundant isotope of oxygen. So, 1 gram atomic weight of oxygen is 16 grams. Similarly, 1 gram atomic weight of sodium, symbol of sodium is Na, it is 23 grams. Right. Now I shall give you a question. Magnesium mg. Magnesium mass number is 24. Now tell me, what is the gram atomic weight of magnesium? See, mass number of sodium is 23. Therefore, gram atomic weight of 1 gram atomic weight of sodium is 23 grams.
Okay.
Similarly, mass number of magnesium is 24. What is the gram atomic weight of magnesium?
24 only, sir.
24 grams. Very good. You are answering very nicely. So, gram atomic weight of magnesium is 24 grams. Have you got this gram atomic weight constant? Okay, I shall give you one more example. Mass number of aluminium is 27. Mass number of aluminium is 27. Then what is the 1 gram atomic weight of aluminium? 1 gram
27.
atomic weight. How much?
27, sir.
27 grams. So this is very simple. So you understood very well now. So the atomic number, that is mass number, if mass number is expressed in terms of grams, it is nothing but gram atomic weight of that particular element. Have you got it?
Yes, sir.
Very good. Now let us proceed to next. Gram molecular weight. Molecules means molecule has more than one atom. More than one atom. For example, oxygen. Oxygen molecule equal to O2. This is element. Some elements exist in molecular form also. For example, O2, H2, N2, F2, Cl2, etc. These are referred as diatomic molecules. Diatomic molecules. Right. Now let us see some compounds. Compounds. Molecules of compounds. Sodium chloride, common salt, as you told just now, common salt. Right. Now, the carbon dioxide. Carbon dioxide. It's a molecule. What is the molecular formula of carbon dioxide? CO2. Now, molecular weight. Molecular weight means weighted average, remember. See, we do not use every time weighted. Molecular weight means weighted average. Okay. So, in one molecule of carbon dioxide has one atom of carbon and 2 atoms of oxygen. So, to get the molecular weight, what we have to do? We have to add the atomic weights of individual atoms completely. So, molecular weight of carbon dioxide equal to atomic weight of carbon into number of atoms. That is, the atomic weight of carbon 12, weighted average. 12 into 1 equal to 12 because there is only one atom, one carbon atom. Similarly, atomic weight of oxygen, how many oxygen atoms are there? 2 oxygens. So, atomic weight of oxygen is 16. See, this 16 is atomic mass number, remember. For calculation purpose, we are taking the mass numbers. 16 into 2 equal to 32. Now, you have to add both of these. This is 44. Therefore, molecular weight of carbon dioxide equal to 44. Just like previously, atomic weight, now you express this 44 in terms of grams, then we get gram molecular weight. Gram molecular weight of carbon dioxide equal to, what is this? 44 grams. Have you got this?
Yes, sir.
Now, you can do this very nicely. H2O water, GMW. Gram molecular weight of water is hydrogen, 2 atoms are there, 2 into mass number 1 plus oxygen, 1 atom is there, 1 into mass number 16. Therefore, this is nothing but 18. Have you got this?
Yes, sir.
Now, at the end of this module, you will get an assignment and you have to do this assignment and submit to me tomorrow. Okay.
Okay, sir. Okay,
Now,
sir.
let us proceed to next. Atoms of an element has a certain mass, but this mass is too small to measure, as I discussed just now. So, mass of an atom was found to be very, very small. This we discussed already. But experimentally, a fixed mass of every substance has a fixed number of particles. This fixed number of particles is referred as Avogadro number. Avogadro, an Italian scientist, after doing so many experiments and of course after discussing, after analyzing, after interpreting the concepts introduced by various scientists, he proposed this number, that is Avogadro number. What is Avogadro number? Avogadro number value is 6.022 into 10 to the power 23. So the mass of Avogadro number of any substance is referred as molar mass and it is referred as 1 mole. So here, now just now we discussed that oxygen gram atomic weight, how much we discussed? 16 grams. So this 16 grams of oxygen has 6.022 into 10 to the power 23 atoms of oxygen. Oxygen atoms, remember. Similarly, dioxygen means O2. Molecular weight of dioxygen is 2 into 16 equal to 32. So, 1 gram molecular weight of dioxygen is 32 grams. 32 grams of O2 has same number of molecules, that is 6.022 into 10 power 23 molecules of oxygen. So this is Avogadro number. Have you got it?
Yes, sir.
Yeah. Now let us extend to the last one, the mole concept. See, as we discussed just now, see here, this is the mass of Avogadro number of any substance is referred as molar mass, or it is referred as 1 mole. Now, so mole means, mole is nothing but mass of Avogadro number of particles. Mass of Avogadro number of particles. Okay. Now let us see sulfuric acid, H2SO4. Sulfuric acid formula is H2SO4. Let us find out molar mass. To find the molar mass, we have to add the atomic masses of each and every element. Element, number of atoms into atomic weight or atom mass number. So hydrogen, 1 into, how many atoms? 2 atoms, 2 into 1. Sulfur, 1 atom into 32. Oxygen, 4 atoms into 60. So this is 2, 32, this is 64. How much it is? 98. Therefore, 98 grams of sulfuric acid is nothing but 1 gram molecular weight, or it is also called as 1 mole. 1 mole. So 1 mole, this 1 mole of sulfuric acid has how many more particles?
98 grams.
Just now I told this is Avogadro number of molecules, 6.022 into 10 power 23 molecules of sulfuric acid. Okay, have you got it?
Yes, sir. Yes, sir.
Very good, nice. Now, see, I shall post an assignment. So just you carry on that assignment and of course get to me, and you can understand the subject very well. Thank you very much.
Thank you, sir.
Stop sharing, Anna.
Stop sharing.